This is problem from page 29. So let's see how do we see this is do we see any special triangles? We know that 3, 4, 5.
Yes, in fact, we do see a 3, 4, 5 triangle in example 1.
3K, 4K, and 5K. Yep. Can you explain how do you see this one is a part of 3K, 4K, and 5K?
Well, we know 2 of the sides already. We know 24 and 30. If we label that as 4K and 5K, we see that K is equal to 6.
This is 5 times 6. This is 4 times 6.
This means that this must be 3K, 3 times 6, and that's 18.
3 times 6, which is 18. It's correct. We got that one. What about number 2? What other triangles, well-known triangles do we know? This seems like what it reminds you.
It reminds me of the 8, 15, 17 triangle. 8K, 15K, and 17K.
15K and 17K. Then this
K in this case would be 3, I think, because 8 times 3, 15 times 3 is 45. So thus, X is 17 times 3, which is 51.
So we don't have to deal with this 24 square, 45 square, and X square, right? That's great.
Yeah, we don't have to deal with Pythagorean theorem.
Great. Let's think about this one. What about, should we deal with this equation, or can you make any connection with number 3 to the well-known Pythagorean triples?
We don't have to expand that equation out. There's a quicker way. I do see a triangle, a Pythagorean triple in this triangle. I think this could be a 6, 8, 10 triangle because the lengths of the sides of the triangle are consecutive even integers.
That seems good, which means this is 8. This one's
and
6.
Then 6, and then 10.
This one's 10. I think that fits perfectly. What's our motto? Avoid hard work, be smart.
Yes. Right? Yeah.
What about this one, number 4?
Similar to number 3, number 4, you don't have to expand an equation. You can think what a well-known Pythagorean triple corresponds to these measurements. And it reminds me of an 8, 15, 17 triangle. 8 plus 7 is 15, 8 plus 9 is 17, and then we have 8.
Okay, then this is going to be 8. This is 15. This is 17. Yep, that's perfectly fit. Page 30. Let's try to visualize the situation. The 3 sides giving. This one is a 4 root 3. The other one is 1. And the largest side, 7. So we might think this problem requires law of sine, law of cosine types of trigonometric equations, but what do we think? How do we approach this one without using those?
Well, first we should see if this is a triangle, a type of triangle that we know about. Like, let's see maybe if the sides form a right triangle.
How do we make sure that 1 square plus 4 root 3 square and 7 square? Let's think this one. This is 1. What is 4 root 3 square?
48.
48
equals 49, which is correct.
Oh, this one becomes correct. That means
it's a right triangle.
This one is right triangle. Then this could This question would ask the area of this figure, right, as well.
Yeah.
What will be the area of this figure?
It would be 4 root 3 over 2. So 2 root 3.
2 root 3. That is correct. Okay, that's a good solution. Let's move to this one. Another side problem. Page 30, chapter 2. So one of our responsibility when we see isosceles triangle is what?
To label the two angles that are equal
and
and the sides as well.
Make what?
Make a perpendicular bisector.
Perpendicular, yes. In this case, bisector, it's going to be a length bisector, right?
Mm-hmm.
This part, let's say this height, it's going to be a half, right?
Yes.
That means half of BC. But we don't know the value of BC. What you could say, this is let's say the value of this is A. What would be the value of BH?
BH is 4 plus A.
Then, so we focus now two triangles. One is this one, the green triangles. The second one would be this one, right?
Yes.
Then we use, let's see, we are going to use, okay, from the triangle 1, what do you see here? H squared, or
H squared is equal to 36 minus 4 plus A squared.
Then from the triangle 2,
H squared is equal to 16, 4 squared, minus A squared.
just A squared.
And now we can set these two equal to each other.
That is correct. Then we set to equal 36 minus 16 minus A squared minus 8A. I'm doing a little bit faster operation. 16 8A minus 16 minus A squared. I can cancel A. I will find A is equal 1/2. That will be faster, but it looks 1/2. Then once you find A equals 1/2, what is next?
Well, we can plug in 1/2 to 4 plus A and A, because we need to find BD, which is the combined length 4 plus A plus A. Mm-hmm. So 4 plus 1/2 plus 1/2, that's the same as 4 plus 1, which means BD is equal to 5.
BD becomes 5. That is correct. So the value of BD becomes 5. Good. Another side problem, giving that DC, this part is 8, AC is 10, BD is 4, then what is the value of, it means the shortest distance from point B to the side BC means this one, right?
Yeah, length BH.
So we are looking for this length. So what do we do? What known angle, known side do we know? Or
Well, I can see just looking at this problem that AD is 6 because it would form a 6A10 right triangle.
his length becomes 6, right?
Yes.
Good. So once we get this 6, then what's next? What idea we can use? The area. How do we use area idea?
We can represent the area of this triangle through two ways. The first, we can say the base times the height, which is 4 plus 8 is 12, the base, and the height is 6, so 12 times 6 over 2. That's one way to represent it.
Or let's go from this one. Whole length. Area of ABC.
Yeah, that's what I said. 12
times
over 2.
12 times 6 over 2. That's also, what's the second way to represent?
Using the other base and height, in this case AC, which is 10, and the height is x, 10 times x over 2.
Then 12 times 6 is 72, right?
Yeah, so 10 times x would be 7.2.
That seems nice solution, which is understandable and clear. Great.
Yes.
Let's see. Another interesting, try this problem, page 33. When you see the midpoint from here, it's better to make a parallel line to create another midpoint to other side. But how do I understand? How do you manage the EM or MC?
Well, first, do you want me to tell you the length of the midpoint, Professor?
Yes, sure.
Length of MD is going to be 4. The reason for this is these two are equal. AD and BD are equal, which means that the smaller triangle, this triangle here, it's a 1:2 ratio with this triangle over here.
Great. Nice point. Now, what do we see? How do you manage the MC and EM?
Well, this is the same. These two lengths are congruent. So, and we know the whole length is 10. So this is 5 and 5.
This is 5.
Yeah, and this is also 5. So what's left over? 3 plus 2. EM is 2.
This squiggly part will be 2. That's great. So then this is 90 degree. What do we see here?
Pythagorean's theorem to find the missing DE. 4 squared plus 2 squared, that's equal 16 plus 4, 20. X is equal to square root of 20, which is 2 root 5.
So DE becomes root 20 to root 5. I think that is nice solution, understandable. Great. That is this problem, our chapter 2 last side problem, page 34. There's a bunch of ways to doing this one. Now, let's use the angle chasing. To use the angle chasing, where should we start? So, can you tell me what's this angle? This.
You can represent it as 90 minus alpha.
And let's put the length. We know this length 1. We know this length, right?
5.
5. Great. Then, do you see any other nice angle that help us, or 90 minus alpha types of angle? Or
yeah, I do. In fact, right here, this could be represented also as 90 minus alpha.
Why?
Because the whole angle here is 90, and then this section is alpha. So this would be 90 minus alpha.
Good. Then once we see both D and B, ADB and DBA, they are equal each other, congruent, then can we say what two lengths are
Ooh,
also same?
these two, this would be an isosceles triangle, which means that this length is equal to this length, which means that AH, 1 plus 4, is 5. So AH is 4.
Wow, this is 4. This is very good. 4. Then what's next?
Well, we need to find the area of ADB, which means we need to know the height. And the height, this is a 90 degrees, so this is a right triangle. Well, we know 4 and 5, that means that this will be 3.
Good.
And now
Then
to find the area.
final point of this
Yeah,
problem would be
we do 1 plus 4 is 5. That's the length times the height
area
is
would be
over 2.
5
15,
times
3. 15 over 2 is 7.5.
Wow, that's nice solution. That's end of the chapter 2 side problems.